So, good day everyone. So, this is the third chapter of Mathematics in the Modern World, which is the problem solving and reasoning. So, the first lesson of this chapter is about the inductive and deductive reasoning. Okay, so for learning outcome, at the end of the lesson, you should be able to first discuss the concept of inductive and deductive reasoning. Next is to compare and contrast the inductive and deductive reasoning, solve problems involving inductive and deductive reasoning. So those are the four learning outcomes for this lesson. Okay, so for introduction, so most occupations require good problem solving. So for instance, architects and engineers must solve many complicated problems as they design and construct buildings or more modern buildings that are aesthetically pleasing, functional, and that meet stringent safety requirements. So two goals of these chapters are to help you to become a better problem solving and demonstrate that problem solving can be enjoyable experience. Okay, so for inductive reasoning, it is the process of reaching a general conclusion by examining a specific example. Okay, so it is also defined as a type of reasoning that draws a general conclusion from a repeated observation of a given data or a given data. Then we draw conclusion based from the frame of this data or simply from a specific case or to general case. Okay, so the conclusion drawn by using inductive reasoning is called the conjecture. So here in inductive reasoning, okay, so we examine and we generate conclusion by examining a specific example. So we give a specific example, and through that specific example, we're going to generate a conclusion. And then the conclusion we're about to make is what we call the conjecture. Okay, so example of inductive reasoning. Use the inductive reasoning to predict the next number in each of the following lists. So the list of numbers are 3, 6, 9, 12, 15. So what could be the next? So if we're going to analyze this series of numbers, okay, so what is the relation of the first term to the second term to the third term to fourth term, and then fourth term to fifth term? And then if they have relation, so what could be the next? Okay, as we observe, in each successive number, so there are multiple of 3 or divisible by 3. Okay, if we're going to multiply, they are all divisible by 3. Okay, 3 is divisible by 3, 6 is divisible by 3, 9 is divisible by 3, 12 is also divisible by 3, 15 also is divisible by 3. So what other observation? Okay, as we can see, we're going to get the difference of 6 minus 3. So it will result 3. So same thing with 9 minus 6, 12 minus 3, 9, 15 minus 12. Okay, so they all have the common difference of 3. So meaning to say, okay, the second digit or the second term is 3 larger than the first term. So meaning to say, nag-a-add siya. Okay, nang by 3's. So 3 plus 3 is 6. 6 plus 3 is 9. 12 plus 3, 9 plus 3 is 12. 12 plus 3 is 15. So what could be the next? So 15 plus 3 is equals to 18. So in that case, specific yung example natin, specific yung target natin. So that therefore, this is an example of inductive reasoning. Okay, so how about this example? We use inductive reasoning to predict the next number in each of the following lists. Okay, what are the list of number? We have 2, 5, 10, 17, 26. Okay, let us analyze the given set of numbers. Okay, so as we can see, Okay, so what is the relationship of 5 sa 2, 5 to 10, 10 to 5, 17 to 10, 26 to 17. So let's try to get its difference. So we have 5 minus 2, that is 3. Okay, that is 3. 10 minus 5, so this is 5. Okay, 17 minus 10, this is 7. And then 26 minus 17, this is 9. So as you observe, so what happened to their difference? Okay, if we're going to observe the difference of those set of numbers, they are all odd numbers. Okay, so 3, 5, 7, and 9. So it is possible that the next number added to 26 is 11. Okay, so since they are all odd numbers starting with 3, okay, so we can say that the possible, okay, the possible number that we should add to 26 is 11. So 26 plus 11 is equals to 37. Okay, so that's the answer for it. Okay, so next is, let us use inductive reasoning for making a conjecture. So let us use this procedure. Pick a number, multiply by the number by 8, add 6 to the product, divide the sum by 2, and subtract 3. Okay, so for example, our original number is 5. Okay, so according to the procedure, okay, so we need to multiply 5 by 8. So that is 5 times 8 is equals to 40. Next, add 6 to the product. So we have 40 plus 6 is equals to 46. Next, divide the sum by 2. Okay, so 46 divided by 2 is equals to 23. And then subtract it by 3. So 23 minus 3 is equals to 20. So the resulting number is equals to 20. Okay, so that is the making of conjecture. Okay, so next, let us compare this one to the next example. Okay, so for example, our original number is 6. Okay, again, same procedure. Okay, multiply by 8. So 6 times 8 is 48. Okay, add 6. So that is 48 plus 6 is 54. Next is divided by 2. 54 divided by 2 is 27. Okay, subtract it by 3. 27 minus 3 is 24. Okay, and that is the resulting number. Okay, so ngayon, let us identify, uh, let us make conjecture by their result. So in 5, okay, when we use original number as 5, so its result is 20. Okay, when we use 6 as our original number, the resulting number is 24. So what is the connection of this number, of the original number, to resulting number? Okay, so in this case 20, what is the relationship of 20 sa 5, or 20 to 5? And then what is the relationship of, okay, 26 to 24? Okay, if we're going to divide the resulting number by the original number, what happened? We're going to divide 20 by 5, so that is equal to 4. Okay, and if we're going to divide 24 by 6, it is also equal to 4. So therefore, when we start with 5 and follow the procedure to produce 20, starting with 6 as our original number, it produces the final result of 24. So in this case, the resulting number is 4 times the original number. So totoo naman, di ba? Okay, if our original number is 6, okay, if we're going to multiply 6 by 4, and then it will result as 24. If our first original number is 5, if we're going to multiply 4 by 5, So it will produce 20. So meaning to say, in making conjecture, in each of these cases, the number is 4 times the original numbers. So that is our conjecture. Okay, so let us use inductive reasoning in real-life scenarios. So scientists often use inductive reasoning. For instance, Mr. Galileo Galilei, so 1564 to 1642, used inductive reasoning to discover that the time required for a pendulum to complete one swing, called the period of pendulum, depends on the length of the pendulum. So Galileo did not have a clock, so he measured the period of the pendulum in heartbeats. So in this time, okay, so Galileo discovered that the period or once the complete one swing or the period of pendulum is depend on the length of the pendulum. So meaning to say, uh, nakadepende ang uh, measurement ng period ng pendulum ay yung isang swing ng pendulum sa length ng pendulum. Okay, so at that moment, uh, maybe during that time, Galileo did not have a clock, so he measured the period of pendulum through his heartbeat. So for convenience, okay, so the table that I'm going to show you to the next slide is the length of 10 inches has been designated as 1 unit. So for you to understand, here is the table. Okay, so for the first column, we have the length of pendulum. So it in units. That is what I'm going to this is what I'm saying to you a while ago. So in units means 1 unit is equal to 10 inches. So 4 units means 40 inches. 9 units means 90 inches. So 16 units is equal to 160 inches. So 25 units is equals to 250 units, and then 36 units is equals to 360 inches. Okay, so according to the table, okay, in 1 unit, it is equivalent to 1 heartbeat. Okay, in 4 units, it is also it is equivalent to 2 heartbeats. Okay, next is for 9 units. Okay, it is equivalent to 3 heartbeats. And then for 16 units, equivalent siya sa 4 heartbeats. Okay, 25 units, it is equivalent to 5 heartbeats, and 36 units, it is equivalent to 6 heartbeats. So the question is, let us use inductive reasoning in making conjecture. So the question is, if the pendulum has a length of 49 units, what is its period? Okay, so if the pendulum has a length of 49 units, okay, so what is its period? So let us analyze the length of the pendulum in units. So okay, as we observe, so what is the relationship of 4 in 2, 9 in 3? Okay, so what is the relations of 16? Okay, to 4, and then 25 to 5. So what is the relation of 36 to 6? So okay, if we going to analyze it, okay, so 4 is the square root of 2, 9 is the square root of 3, uh, rather 3 is the square root of 9. Okay, square root of 16 is equals to 4. Okay, square root of 25 is 5, and then square root of 36 is 6. So therefore, if we're going to get the square root of 49, we're going to get the square root of 49. Okay, it is equal to its period. Okay, so square root of 49 is equals to 7. So therefore, if the pendulum has a length of 49 units, its period of pendulum is equals to 7. Okay, next. Okay, So in this case, if the length of the pendulum is quadrupled, what happened to its period? So let's start with 1. Okay, quadrupled means times 4. It is times 4. Okay, so let's start with 1. Okay, if 1 unit is equal to 1 heartbeat. Okay, so if we're going to multiply 1 by 4, it will result as 4. Okay, so and the period of pendulum when the length is 4 is equals to 2. Okay, next, if we're going to multiply 4 by 4, it will result as 16. Okay, and if the length of the pendulum is 16 units, its heartbeat is equals to 4. So the question is, what happened to the period if the pendulum is quadrupled? So we're going to analyze, let us analyze the heartbeat. So we have 1, 2, 4. So what happened to the heartbeat? Okay, it is, okay, the period uh, is divisible by 2 and then nagdo-double siya, di ba? So, it appears that when we quadrupling the length of the pendulum, it doubles the period. Doubles the period. Okay, so tingnan natin, di ba? If the pendulum is 1, the heartbeat is 1. The pendulum is 4, okay, na-double yung 1, it becomes 2. Okay, if the pendulum is 16, na-double yung 2, it becomes 4. Okay, next, deductive reasoning. So, it is a process of reaching conclusion by applying general assumption, procedure, or principle. Okay, so here we use general example and as our assumption. Okay, so it is showing a general to specific case. Okay, so, and then the last one is deductive, start with general statement or hypothesis and examine to reach a specific conclusion. Okay, so for you to understand, here is our example. Okay, consider the following procedure. So let us use the deductive reasoning to show that the following procedure produced a number that is 4 times original number. Okay, so pick a number, multiply the number by 8, add 6 to the product, and divide it by the sum by 2, and subtract by 3. Okay, so in deductive reasoning, we use general example. So in this case, let us use n as representation of a general number. Okay, n also stand for the variable. Okay, so let's follow the procedure. So multiply it by 8. So that is n times 8. So that is equal to 8n. Okay, next, add 6 to the product. Okay, so 8n plus 6. So that is equal to 8n plus 6. Okay, divide the sum by 2. So 8n plus 6 over 2, that is equals to 4n plus 3. And then last one is subtract it by 3. So 4n plus 3 minus 3, and that is equals to 4n. Okay, so the resulting number is 4n. So like what I've said kanina, okay, so we use deductive reasoning to show that the following procedure produces the number that is 4 times the original number. So if we're going to recall our example in inductive reasoning, where n is equals to 5, okay, so 4 times 5 is equals to 20. And if we're going to replace n by 6, so 4 times 6 is equals to 24. So as we stated with the n, and it end up with 4n. So the procedure given in this example produce a number that is 4 times the original number. Okay. So next, determine the type of the reasoning. So this, okay. Determine whether each of the following arguments is an example of inductive or deductive reasoning. Give an example. During the past 10 years, the tree has produced palms every other year. So last year, the tree did not produce palms. So this year, the tree produced palms. Okay, so for example, in 10 years, the first year, the palms did not produce palms. The tree did not produce palms. Okay, and the second year, it produced. Third year, it did not produce. Fourth year, it produced fruits or palms. Okay, so in fifth year, okay, it did not produce palms. Sixth year, nag-produce siya. Okay, sa seventh year, hindi siya nag-produce. Eighth year, nag-produce. Ninth year, hindi siya nag-produce. And then, 10th year, nag-produce siya. So, as we observe, there is a pattern that every other year, or alternating year, nagpo-produce yung tree ng palms. So, in this condition, so sabi rito, last year, the tree did not produce palms. So, this year, the tree will produce palms. Okay, this is an example of inductive reasoning kasi may basis, okay, yung example na specific yung case natin. Okay, next. So determine whether each of the following arguments is an example of inductive and deductive reasoning. Okay, so the given problem, all home improvements cost more than the estimate. Okay, all home improvement costs more than the estimate. The contractor estimated that my home improvement will cost 35,000 pesos. Thus, my home improvement will cost more than 35,000 pesos. Okay, so what kind of reasoning is this? Okay, so analyze natin. So, the first sentence, it says that all homes improvement costs more than estimate. So, dito meron siyang hypothesis na lahat daw ng home improvements will cost more than the estimate. So, when the time the contractor when the time that the owner of the house or asked the contractor to estimate his home, okay, so it will cost 35,000. So therefore, he has a conclusion that, okay, that his house improvement or home improvement will cost more than 35,000 pesos. So since there is a hypothesis, okay, so this is an example of deductive reasoning. So in this case, because the conclusion is specific to general assumptions, so this argument is an example of deductive reasoning. So, from specific, which is 35,000 pesos, at naging general, nasabi niya rito, more than, okay, 35,000 pesos. So, therefore, it is a deductive reasoning. Okay, so that's all for today. Thank you for listening. Keep safe and God bless.